We're asked to prove that a line through A and P, that is line AP, is a tangent of the smaller circle. So this is a circle statement question. You've got to think how we're going to prove this. And actually, once you realize how you're going to prove it, it might jump out at you. The way that you show that something is a tangent to a circle is by showing that it is 90 degrees to the radius. So that's going to be the aim. And once you realize that, then hopefully this circle theorem will pop into your head. If you haven't seen it, then it's not going to pop into your head. But basically, the circle theorem is if you have a circle and then you have a diameter, any triangle you draw will necessarily be right angled. I'm going to prove that at the end, and you could figure that out in this question potentially. I think that would be quite hard, but yeah, we're going to use that. So basically, prove it. So this angle here, angle APC, equals 90 degrees angle in a semicircle. Therefore, AP is perpendicular to the radius. We need to cite that, the radius CP. Hence, AP is a tangent. Okay, that is another circle theorem, that one in blue, and we can just quote it. We don't need to prove it. It just glances off the circle and it will be at 90 degrees necessarily. So that will be sufficient for this question. Now let's just go ahead and actually prove this circle theorem because it's really good. I'm going to prove it by like all the circle theorems come from isosceles triangles. So essentially I've created two isosceles triangles here. This one in green and then this one in purple. Now here's how you can do it. You can label this angle A, and then this one will necessarily be A as well, since it's isosceles. And then you can label this one B, and this one is also B, again, because this is the same length. Now, it must be that 2A plus 2B is equal to 180, because these are just the angles in the triangle. And so if we divide by 2, you might want to factorize it out first. You don't have to. Divide through by 2, then we're going to get 90 degrees. Okay, and that's what this is saying here. We've just proven for any triangle drawn using the diameter in a circle, this angle at the edge will be 90 degrees. That's not needed in this question. Let me just state again. Okay, you just need to basically quote angle in a semicircle, and then you say that that is the radius here, PC, and therefore AP is perpendicular to PC, and we're done. But this was just explaining why.